Hi there, my name is Ben, and I'll be presenting a review of existing test methods for occupancy sensors. Have you ever been working in an office and the lights turn off on you every few minutes because you haven't moved enough? This is the kind of problem we hope to solve, so that occupants are less frustrated and thus more accepting of energy-saving strategies like occupancy sensors.
Solving problems with occupancy sensors yields enormous energy savings. Lighting in commercial buildings throughout the entire country could be powered all year, just from the energy savings from occupancy sensors in those buildings. Prior test methods, such as the one published by the National Electrical Manufacturers Association, or NEMA, only apply to certain popular occupancy sensor technologies, limiting the ability of new occupancy sensors to overcome the shortfalls of prior installations. A new technology-agnostic test method would be required to make an apples-to-apples comparison between a wider variety of technologies on the market, complete with both the strengths and weaknesses of each system under test. To understand what a new technology-agnostic test method might look like, we reviewed over 200 studies and consolidated 33 into a literature review as a cross-section of market-available occupancy sensor technologies and typical test method conditions to characterize those sensors. Here, we show the cross-section of occupancy sensor technologies achieved in the review. And here, we show a cross-section of test conditions typical in occupancy sensor studies, including a test method that cannot be accommodated by any prior well-described and published test methods for occupancy sensors, such as the NEMA test method. As a result of the literature review, we established the following series of suggestions to improve occupancy sensor characterization in a technology-agnostic manner, which we will illustrate in the following slides. The first suggestion is to evaluate spatiotemporal properties, or STPs, if functionality is claimed by a manufacturer of an occupancy sensor. STPs include presence, is at least one person present, count, how many people are present, location, where is each person, track, where was this person before, and identity, who is this person, and is this person John? STPs are arranged in a strict hierarchy, where more information is required as you go down the list. As an example, if the occupancy sensor fails to detect presence at any time, all the following higher functionality is disabled. It is so important to resolve the current issues with commonly installed occupancy sensors being unable to maintain a state of presence. The valuable higher level functionality is simply not accurate without it. Presence is perhaps the most difficult for common occupancy sensor installations and is why lights turn off on us when we are still in a room. It can be broken down into 5 states of presence. Major motion is walking through a room. Minor motion is a movement similar to reaching for a phone. Hand motion is similar to typing, while stillness and absence are just that. We suggest facilitating multi-device sensing systems, meaning more than one sensor collaborating to establish claim functionality. We suggest utilizing defined obstruction simulations such as a desk, bathroom stall, and shelf, which should be appropriate for the application or applications the occupancy sensor is intended for, and one or more rooms of defined sizes. And lastly, we suggest establishing ground truth with a method of greater fidelity than the sensor under test, monitoring and controlling dry bulb temperature and relative humidity within a specified range typical to indoor spaces, and utilizing sources of false stimuli that might cause false triggering of the sensor under test. Following the prior suggestions, a future test method prototype should be capable of facilitating the characterization of all occupancy sensor technologies available on the market today. The new technology-agnostic characterizations will provide valuable insight to specifiers and users before their investment, ensuring they can avoid the pitfalls of many common sensor technologies that have led to widespread occupant frustration.
Thank you so much, and if you have any questions, please feel free to contact us.